Yes, sir.
So, okay, you are Kavya Mansa, right?
Yes, sir.
Okay. So can you tell me what are avial trees? What is an avial tree?
I can't hear, sir.
Am I audible now? Is it clear?
Self-balanced binary tree, sir. Consider
Come
an
again?
a given set of elements which are forced a given set of elements which are
అమ్మ తెలిసిపోతుంది.
forced, sir. The operators are inserted and deleted, sir.
Okay. So I want others to mute yourself. Okay.
Sir,
So students who are not talking, please mute yourself. Okay.
okay, sir.
Can you tell me what is the balance factor? What is
Balanced
the
fact.
balance factor of a node for in an avial tree?
Balanced factor is subtree of left subtree minus right subtree, sir.
Okay. So based on the balance factor, what we are going to uh, do? So on what basis we'll be using this balance factor? So what is the requirement for using the balance factor?
Balanced factor.
So now you will calculate the balance factor, right? You know how to calculate. You said left subtrace minus right subtrace number of nodes. So based on the balance factor, what you are going to do?
The basics of balance factor in avial tree relies on the difference in height between the last and right subtree of a given node. This balance factor concept enables to avial tree to maintain a balanced structure, sir.
Balance stage. Okay. Okay. Can you tell me what is priority queues? What are priority queues?
Priority, sir.
So what type of priority queues are there?
No, sir.
Like you have heard about min priority queue, max priority queue, right? So what is min priority queue?
Water,
What is min priority queue? Min PQ.
water amplitude, sir.
Min priority queue. Minimum priority queue.
Minimum priority,
Queue.
minimum priority to us, sir. Minimum
Priority
priority,
queue. Yeah.
minimum priority queue.
Yes.
Um, no, sir.
Okay. So you have this minimum number of nodes, right? So whenever you have minimum number of node value, so you'll be replacing that with the maximum node value. So at any point at the top of the node, you will maintain the minimum value. So you'll be make sure whenever you're inserting each and every element, you will replace the new element with the minimum value and make sure the top node has minimum priority queue. So now, did you get a glance what you exactly learned in min and max PQ?
Okay, sir.
Okay. Just go through that once again, min and max Q. Okay, no worries. So one more question. So when I come back to avial trees, so what is the uh, what is the rotations? What are the rotations that we use in that we have in avial trees?
Left right rotation, right left rotation, left rotation, right rotation, sir.
Good, perfect. Okay, so we'll go to the next person. Harita, is Harita on the call? Harita, 4258 roll number.
Yes, sir.
Yeah. Can you tell me what are min PQs, min priority queue?
A mini property queue is the specialized data structure structure were remained, sir, properties based on values with the smallest values, sir.
Okay. Can you tell me what is PQ? What is PQ? Max PQ.
Max large, strongest values, sir.
Can you come again? What is maximum PQ?
What, sir?
Maximum PQ. Max PQ.
No, I
Okay. So we'll go to the next question. So you might have seen some of the algorithms using backtracking and greedy algorithms, right? So do you have any idea what is backtracking algorithm? Backtracking algorithm.
backtracking is one node with a such technique use data algorithm.
Hmm.
Sir, backtracking is a problem solving algorithm, sir. Involves exploring possible solutions and algorithm.
Yeah, continue. On yeah. Continue.
Exploring possible solutions and
So you'll be exploring different kind of solutions
yes,
on a repetitive basis,
yes,
right?
yes.
Okay. So tell me one thing. So backtracking approach itself is it optimized approach?
But, sir, optimization backtracking approach is casual when dealing with a complex problems.
Hmm.
Backtracking solution from quantity. Optimization helps to the searching space and minimalization the time spent exploration the unpromising paths. Sir.
Okay. So maybe can you also give me one example where we have used backtracking? One of the example. Like we have you have solved few. Yeah. Please carry on.
The depth search space.
Okay. That is so whenever you want to find a shortest path or shortest depth, you'll be using this algorithm. Okay. So we'll go to the next person. Srikanth. Is Srikanth on the call? Is Srikanth on the call? Hemant?
Sir?
Yes.
Yes,
Yes.
sir.
Oh, okay. Can you tell me an example of dynamic programming, or what is a dynamic programming?
What, sir?
What is dynamic programming?
Don't know, sir. Next question.
Do you heard about breadth first search and depth first search?
Yes, sir. No.
You heard?
Yes, sir.
You are aware of it? Breadth first search and depth first search.
Yes, sir.
Yeah, can you explain me what is breadth first search and depth first search?
Okay, sir. So the depth for search means hello. DFS means
Yes,
depth
yes.
for DFS means hello.
Yes, I can hear you. Please carry on. What is breadth first search and what is depth first search?
DFS means depth initial search, sir. Okay. Hello.
Yes, yes. Explain me about.
DFS is algorithm that starts with first node, sir.
Hmm.
And it uses for networking to explore.
Or maybe can you tell me how do you traverse through breadth first search? So you're saying, as you already said, it will start from first node, right?
Yes, sir.
So in which direction you'll be moving going forward? From starting from first node, in which direction you'll be moving in breadth first search?
Right, sir.
Height. So you'll start with level 0, then level 1,
Level 1,
and
level
then
2.
level 3. Right. And what is depth first search?
Sir, depth for search means depth first search. It's an algorithm for searching a graph or a tree data structure.
Okay.
The algorithms start at the first node, sir.
Okay.
You also tell that they start from the 0, level 0, level 1, level 2, and so on.
Okay.
Start
Okay.
from the level 0. Start.
Okay. Okay. So you are Hemant, right? 4525 roll number. Okay. Danush, is Danush on the call? Four, 5, 3, 1. Danush. 4518.
Yes, sir.
Yes. 4518 roll number.
Yes, sir. Yes, sir.
Yes. Okay. Your good name?
Divya Saruparani, sir.
Right. Divya, can you explain me? Yes. Can you explain me what is quick sort?
Sir?
Quick sort. Quick sort. Quick sort.
Quick sorter, sir.
Yes. Yes.
Yes, sir.
So how you will sort an array using
Divide and
quick sort?
concept approach, sir. Fasting and efficient. In place sorting, no extra strong is needed, sir. How it works? Choose a pivot element. Partition the array around the pivot. Recursively sort subarrays.
Okay.
Select a pivot middle element, partition left element pivot, sir.
Okay.
So it is a sorting technique, sir.
Okay. Can you also tell me what is merge sort?
What, sir?
Merge sort.
Sir?
Merge sort. I can't hear you. I'm asking about merge sort. You're on mute if you're talking.
Yes, sir. Yes, sir. Merge sort is a popular, efficiently sorting algorithm, sir. Divide and consequence approach, sir.
Okay.
Time complexity O n log n, sir.
Okay.
Divided the race to Halvin, sir.
Okay.
So that's it, sir.
Yeah. Okay. Thank you. We'll go to the other person. So roll number 4511.
Sir.
Yes. So do you know about minimum PQ or max PQ? Min PQ and max PQ. What is the difference between min and max PQ?
Stores with element probabilities, sir. Minimum
Yes, yeah, go on. You're right. Go on.
elements are ordered by probabilities, sir. And minimum element is always at the top.
Okay, perfect. Yeah.
Extension removes the minimum element, sir.
Okay, and what is max PQ?
Max PQ, a data structure that stores element with the probabilities, where the maximum probabilities elements is always extended first.
Okay. Can you so you have already wrote this code, right? So min and max PQ. You have already learned how to write the code. So I have a question on the code. When you have to insert an element into the PQ, how we are going to insert in a min PQ? So you have an element and you will be putting it into the tree. Okay. How we are going to put that element into the tree?
Create a new node with an given element and probability, and if the head is empty, and add a new node, sir.
Right? Yes.
Bubble up the new node, maintain the head probability.
Okay.
Yes, sir.
So while maintaining when you're inserting the element,
Yes,
what is
sir.
that you are going to check?
We have to check about we can insert a element. It's block of element which I have to check na, sir. It's empty or not when we are inserting element.
Okay. First check is whether it is empty or not, right? What is the second check that you need to do?
We have to check our order also, sir.
Okay.
Yes.
Order in terms of like whether the value is perfect. Yes. And for a max PQ?
I don't know, sir.
So like it's the same thing. Like you for min PQ you are checking the minimum. For max PQ you'll check the maximum. Same, it's just reverse, right?
Yes, sir.
Yeah. Okay. Thank you. We'll go to the next person. 4540 roll number. Roll number 4540.
Yes, sir.
Okay. Right. Can you tell me what is merge sort?
Med sort, sir.
Yes.
Merge-sort is a popular, efficient sorting algorithm. It divides and conquer approach. Stable preserves order of equal elements. It has time complexity.
So can you explain me what is quick sort?
What's it?
Quick sort. Quick sort.
Quicksort is a popular sorting algorithm known for its efficiency and speed.
Okay.
We choose a pivot element from the array.
Right.
Partition the array around the pivot. Elements less than the pivot go to the left, and elements greater go to the right.
Perfect. What is the difference between quick sort and merge sort?
Difference between
Quick sort and merge sort.
Quicksort and merge-sort are two popular sorting algorithms with distinct differences. It divides and conquer approach. In place sorting, no extra storage is needed. Unstable sorting. Recursive partitioning around a pivot. It has the time complexity. Merge sort is stable. Quick sort is
కెమెరా స్ట్రైట్ గా ఉండు.
ఓకే సార్.
నువ్వు స్ట్రైట్ గా ఉండు. స్ట్రైట్ గా ఉండి క్వశ్చన్స్ ఆన్సర్ చెప్పు. ఏంటది ఏది చూస్తున్నావు నువ్వు? ల్యాప్టాప్ చూసి చెప్తున్నావా?
ల్యాప్టాప్.
క్వశ్చన్ కి ఆన్సర్ పర్ఫెక్ట్ గా స్ట్రైట్ గా చెప్పు. అర్థమవుతుందా? ఏంటి అటు ఇటు చూస్తున్నావు ఏంటి? వైవా సెషన్ అన్నప్పుడు కరెక్ట్ గా క్వశ్చన్ కి ఆన్సర్ చెప్పేటప్పుడు కరెక్ట్ చెప్పు. ఆ క్వశ్చన్ ఈ క్వశ్చన్ అటు ఇటు చూడడం ఏంటి? అన్ని అబ్జర్వ్ చేస్తున్నాను. ఎండింగ్ వరకు రిమైనింగ్ వాళ్ళు అయినా సరే ఎవరైనా జాయిన్ అయినప్పుడు స్ట్రైట్ గా ఉండండి. క్వశ్చన్ అడిగేటప్పుడు ఆన్సర్ చెప్పండి. అర్థమవుతుందా? మీరు అటు ఇటు తిరుగుతారంటే ఎలా అవుతుంది? కూర్చో ఒక దగ్గర, స్టాండర్డ్ స్టడీగా ఉండు. క్వశ్చన్ అడిగేటప్పుడు కరెక్ట్ గా ఆన్సర్ చెప్పు. అటు ఇటు కళ్ళు గట్ట అటు ఇటు చెప్పకూడదు. స్ట్రైట్ గా ఉండాలి, ఆన్సర్ చెప్పాలి. రిమైనింగ్ వాళ్ళు అయినా సరే. సార్ కంటిన్యూ సార్.
Yeah. Yes, please continue. Roll number 4540. Explain me the difference between quick and merge sort. Guys, please mute yourself. 4363, mute yourself, please. Yeah.
అమ్మా మీరు రోల్ నెంబర్స్ తో జాయిన్ అవ్వండి. నేమ్స్ తో జాయిన్ అవ్వద్దు, రోల్ నెంబర్స్ తో జాయిన్ అవ్వండి అందరూ. సార్ స్టార్ట్ చేయండి సార్.
Yeah. 4540 roll number. Are you on the call? Four 4522. Four 4569.
Yes, sir.
Yes. Can you tell me what is B tree?
Sir?
What is B tree? Yeah.
Okay, sir. B tree is a self-balancing tree data structure that contains the sorted data and allows the efficient instruction, deletion, and searching operations. It is commonly used in the database and files systems. Sir.
Okay. So can you give me an example where you will be using B tree? Given that, for example, I'm selecting 5 random numbers from a set of digits. Okay. Right? You understood the yes, 5 random elements. Now
Okay, so 5
you
random.
need to you need to put one after the other each element into the tree. Right? So you have 5 elements. Okay.
Okay, sir.
And you need to push that into the tree.
Okay, sir.
One after the other.
Okay, sir.
How you are going to push that element into the tree? In a balanced tree.
Node contain the maximum of n by 2 minus 1, sir, formula.
Right. Right.
M minus 1 keys. You can order 5. You give 5 elements. 5 elements ఇచ్చారు కాబట్టి అది 4 minus 1, sir. 5 minus 1 4, sir. 4 boxes array box తీసుకొని మనం ఇచ్చిన ఎలిమెంట్స్ 4 ఫస్ట్ ఎలిమెంట్ ని తీసుకొని ఫస్ట్ అరే లో ఫిల్ చేస్తాం నెక్స్ట్ 1 by 1 అలా ఫిల్ చేసుకున్నాక లాస్ట్ ఎలిమెంట్ ఏదైతే ఉందో దాంట్లో అది నెక్స్ట్ గా తీసుకొని నెక్స్ట్ అరేలో వేసుకుంటాం నెక్స్ట్ 4 తీసుకొని
Perfect. So if now order my order is 7 now. So earlier you take an order of 5. Now my order is 7. So what is the difference between order of 5 and order of 7?
Order of 5 is contain the 4 arrays, the 4 boxes of arrays, and the 7 contains 6, sir.
Okay. Arrays or elements, whatever it is. 6. Perfect. Okay. Now tell me, whenever you are inserting the 8th element,
sir,
whenever you are inserting the 8th element, how you are going to balance your tree?
ఫస్ట్ ఆఫ్ ఆల్ మనం అసెండింగ్ ఆర్డర్ లో రాసుకుంటాం సార్
రైట్
అసెండింగ్ ఆర్డర్ లో రాసుకుని దాంట్లో ఉన్న మిడిల్ వాల్యూని రూట్ నోడ్ గా తీసుకుంటాం రూట్ నోడ్ గా తీసుకున్న దానికి మనం తీసుకున్న ఆర్డర్ ఒకవేళ 7 అయితే 7 లో మిడిల్ వాల్యూ ఏదైతే ఉందో దాన్ని తీసుకుని రూట్ నోడ్ కింద తీసుకుంటాం సార్
రైట్
తీసుకున్న తర్వాత దాన్ని అలా ఇన్సర్ట్ చేసుకుంటూ వస్తాం అలాగే మీరు 8th ఎలిమెంట్ ని ఎలా ఇన్సర్ట్ చేయాలన్నారు కదా సార్ కానీ అది ఇంపాసిబుల్ గా సార్ మనం తీసుకున్నది 7 ఎలిమెంట్స్ మాత్రమే 7 ఏరే అంటే 7 minus 1 6 మాత్రమే ఎలా అవైలబుల్ ఉంటాయి సార్
ఓకే ఓకే పర్ఫెక్ట్ సో you have 6 elements right whenever you're trying whenever you're trying to put the 7th element also the node don't have the capacity right because node is an order of 6 then what it will do it will create a child node right it will create a child node right so what are the elements will be on the node at this point so I have a node you have all 6 elements because you have your tree order is 7
okay
elements and you are inserting the 8th element
we can't insert the 8th element sir
okay right okay because it's an order 7 we can't insert the 8th element right
8th element yes sir
okay so I will also try to insert 8th and 9th element also just check how we are going to insert but good very good can you explain me what is max PQ maximum priority queue
priority queue Max PQ. Max PQ is a data structure that stores the elements in such a way that element with the highest priority, sir,
Okay.
is always a front or top.
Okay. So I have element 1, 2, 3, 4, 5. 5 elements. What will be the value that I have in my parent node in max PQ?
Sir?
I have
Max
5
PQ.
elements.
Okay, sir. Repeat. Yes, sir.
I have 5 elements. You're getting that right?
Okay, sir.
My elements
sir.
are 1, 2, 3, 4, and 5. And I'm using maximum PQ. Max PQ is the algorithm that I'm applying on it. So now what is the value that I'll have in the parent node?
4, sir.
How it will be 4?
1, 2, 3, 4, 5, sir.
5, yes.
5, sir. 5 is the parent
5.
node, sir. It is a max, yes, sir.
Perfect. And
Yes, sir.
now I have 1, 2, 3, minus 1, minus 5. What will the maximum value?
3, sir. 3, sir.
Okay. Okay, fine. Right. Okay, we'll go to the next number. Good,
Thank
very
you,
good.
sir.
4501. Four five E2. Roll number 45D7. Roll number 45E2. Are you on the call?
Yes, sir.
Right. Can you tell me what is or can you explain me what is backtracking?
Backtracking is a problem solving technique, sir.
Okay.
It use find all solution to a problem by exploring, sir.
Okay. For example.
For example, we use breadth first search tree, sir.
Okay. How breadth first search trees are an example for backtracking? Can you give me? Can you explain me on that?
What, sir?
Can you explain me how backtracking will be applied?
Breadth first search tree.
Backtracking, not breadth first search. Backtracking. I'm talking about. Take. Let's elaborate. Let me elaborate the question. Okay. So if you remember, so we have N-Queens algorithm, right?
Yes, sir.
So
Yes, sir.
we have 5 queens. We need to place 5 queens in 5 by 5 matrix. Okay. How we are going to insert each queen into the matrix? Using
Repeat
backtracking.
question, sir.
You have 5 queens and you
Okay,
need to
sir.
place these 5 queens in the 5 by 5 matrix.
Yes, sir.
And each queen should not collide with the other queen. For example, you know, the queen moves horizontally, vertically, or diagonally, right? So when
Yes,
you're
sir.
inserting one queen, the second queen, when you're trying to insert, it should not fall in the path of the first queen. You're getting my point? Come again. Right. So I have five queens. Okay. I need to place those 5 queens in the 5 by 5 matrix. But the condition here is each queen should not collide with the other queen. Okay. How we are going to insert these queens? Give me an example for 2 queens. That should be fine. I don't require for all 5 queens. Okay, that's fine. Like just check how we are going to insert. Just take some more time and think. Let me jump to the next question. So, do you know about depth first search? Depth first search. Yeah. So, you have already heard about BFT and DFT, right? Yeah. Can you explain me about DFT?
DFC means depth first search, sir. It is a graph transfer algorithm to explore as possible along each branch before backtracking, sir.
Okay.
Yes.
Okay. Just think about the queen's problem that I told you. How we are going to insert each element in the backtracking approach. Okay. We'll move to the next. Yeah.
Yes.
Yeah. Come. Carry on. Yes. Tell me.
Queen 1 is placed in column 1, row 0, sir.
Okay.
Queen 2 placed in column 2, row 1, sir.
If you are going to place queen 1 in column 0, row 1, and
Yes.
if you are going to place queen 2 in column
2, row 1, sir.
row 1, it will fall diagonally, right? It will collide.
Yes, sir. Diagonally, sir.
So it is not thing, right? Each queen should not collide, but if you put it in column 2, row 2 or row 1, it will collide. Okay, just think. No problem. Just think. You just need to put it in a paper. You will get it. Okay. We'll move to the next number. 4344. Roll number 4344. Roll number 4503. Yes. 4344. Yes.
Yes, sir.
Yeah. Okay. So, do you know about quick sort and merge sort?
Yes, sir.
Yeah. Tell me, what is quick sort and what is merge sort?
Quicksort is an efficient comparison-based sorting algorithm that acts by selecting a pivot element from the array, partitioning the other elements into
Okay.
two subarrays.
Okay. And what is merge sort?
Merge sort is another efficient sorting algorithm that follows divide and conquer approach.
Okay. So, are both of these algorithms are divide and conquer approach method?
Yes, sir.
So, then what is the difference? You are right. Both of them are divide and conquer approach. But what is the difference? So are you going to gain something because of quick and merge sort or quick or merge sort?
Quick sort means divides the arrays based on pivot and recursively sort the subarrays. And merge sort is divides the arrays into two halves, recursively them and merges them back.
Merges them back. So can you tell me with respect to space complexity? So what is the difference between yes, you know what is space complexity, right?
Space complexity of quick sort is omega log n, right?
Quick sort is okay.
Log n.
Okay, big of log n. What is merge sort? Space complexity for merge sort. Okay, fine, that's fine. Can you tell me what is AVL tree?
Repeat the question.
What is AVL tree? Okay, we'll move to the next number. 4467. Srikanth. Srikanth, are you on the call? Four double two eight. Pavani.
Yes, sir.
Right. Can you explain me about heap trees? So there are two different types of heap. Yes, go on.
With heap, max heap, sir.
Perfect. What is min heap?
Min heap is a parent node less than parent node always less than to the child nodes.
Right. Max heap?
Max heap parent node it always value greater than to the child nodes.
Okay. Now my we'll move to the we'll just think about the code part. Okay. Now while you're writing the code for min and max heap, so you have imported one of the library, predefined library, Python library. What is that?
I can't understand.
So what is the library that you have used to write the code for min and max heap? Python library, what library you have used?
I don't know.
Okay. So given I have elements of 5 elements. Okay. 3 minus 3 minus 4, 4 and minus 5. Okay. What are the elements? 3 minus 3, 4 minus 4 and 5. What is the value for min PQ? Or min heap?
7, sir.
How it is 7? We have 5 elements. 3 minus 3, 4 minus 4 and 5. What is the minimum value in the heap that we have?
Sir.
It's 3 or minus 3?
Sir. 5 elements. Minus 4, sir.
Okay. And what is the value that you have in the parent node in the when you apply max PQ or max heap?
Sir.
5. Okay, perfect. Okay, can you tell me about greedy algorithms? What are greedy algorithms?
Start with an empty solution.
Okay.
Each step choose the options that provides the most immediate benefits. The greedy choice.
Okay.
Added this choice to the solving if it does not violate any constraints.
Okay, right. So like until unless you'll get the optimized solution, you'll be trying to find the solution for each and every algorithm, right? Each and every method. Right. So one last question. So can you explain me about B trees?
B tree is a self-balancing tree set. B tree which nodes can have more than one key, more than child tree set.
Okay.
All leaf nodes are in the same level set.
Okay. So for example, let's take an example. I'm asking you to construct a balanced tree, B tree of order of 5. Okay. How many elements will have in the node?
4, sir.
Okay. Right. Yeah, that's all. Good. So yeah, I hope I've covered majority of you people. Okay. Thank you, everyone. Thanks for your time.